All right, so in the last video, we talked about syntax analysis, all right? So in the stages of translations, you've got a few factors to keep in mind. The first step is to perform a lexical analysis. Lexical analysis focuses on converting the program to tokens or tokenization, meaning it shortens and simplifies the program itself, right? It simplifies it into a series of hexadecimal or binary numbers. It's like a very shortening version. It shortens it to a single register so that it's much more easier for the computer to understand. Now, the next thing is syntax analysis. Now, before we continue to that, we must know what is a syntax. It is the rules of the programming language. Like in English, we have got verbs, nouns, pronouns, stuff like that. The rules, the grammar of the programming language. Syntax analysis is pretty much the same thing for programming languages. Okay, it's the rules of the programming languages, a certain set of rules that each programming language follows. Like for Python, for example, indentations are very, very important, right? In Python, indentation is very, very important. In Java, second brackets or these curly brackets after, like, let's say you've got a void main function, you write your code, and then you kind of close the bracket. These brackets are important syntaxes. Without these, the programming language will not function properly. Okay, so let's go ahead and erase all this. So syntax analysis is basically the checking of the writing of the language. If you have followed all the rules of the programming language, that is followed by syntax analysis. Okay, now in the syllabus, we don't need to perform any syntax analysis checks on paper 3, neither in paper 4, because this is not part of paper 4. But in paper 3, you're not going to be checking the syntax of a pseudocode. That's not it's done. Instead, we learn and we study that how syntaxes are set up for programming languages. But the task for syntax analysis, it checks if you have followed the rules of the programming language. All right, so it follows a few steps. So let's take a look. All right, so let's have a look at the tasks that you're going to be performing in syntax analysis. The first task is going to be constructing parse tree. All right, constructing a parse tree or a table. So what is a parse tree or a parse table? Well, basically the combination, okay, the combination of a symbol table plus a keyword table, but both of these together are known as parsing. Okay, performing both of these actions together is known as parsing. So basically a parse tree is constructed and the program is parsed. And the program is parsed. The second task is going to be checking the label of the tokens. Checking the label of the tokens to ensure the following. Okay, so that means we use the symbol table and we use the keyword table and we look at this, and then the computer tries to understand sequentially that what comes after other. Basically just read through the programming language and it sees if all the syntax has been followed. And finally, an error report is produced. So the error report may contain no errors, telling us that there were no errors made in the programming language, or it may show us that there were some errors. Okay, so this can be a question or an answer that may be asked for around 3 marks in the exam. So basically, how the syntax analysis process actually works can be represented diagrammatically. All right, so let's go and try to understand it like by using a diagram. Okay, so firstly, you've got your tokens. And secondly, you've got your syntax. This is the rules of the programming language. It's set by the programmer. And in the middle, you've got your parser. And the token, okay, let's say this is the tokens that were made. Let's say 60, 25, 1B, 2B, 3B, FB, 1112. These were the hexadecimal token. The parser checks if the rules were followed. And if the rules were followed, then it's going to be producing no errors, or else it's going to produce an error report and note you that where the particular error has occurred. All right, so that's the job of using the parser, syntax of the language, and tokens. Now these tokens come from lexical analysis. Okay, that's the first step. And the syntax over here, these are predefined. And to predefine a syntax for a programming language, we use a new form. Okay, this is known as a Backus-Naur form, or short form BNF. So mainly, what is Backus-Naur form? So Backus-Naur form is basically a language. It's a very simple language. It's a standardized language that allows for setting up a syntax for a language. In addition to Backus-Naur form, we also use a more simpler version of it, known as syntax diagrams. Okay, this is known as syntax diagrams. So what is syntax diagrams? It graphically represents the Backus-Naur form. So it's a much more simpler way to represent the Backus-Naur form. So in our syllabus, we do need to write simple Backus-Naur form codes and assign syntax. All right. So let's first start with learning how syntax diagram works. Syntax diagrams. So syntax diagram has a few rules. Number one is defining something. Okay, this is something that you want to go ahead and define. Okay, defining. So defining is used for fixed values. Now, by defining, what do you understand? By defining, we're trying to say that let's go ahead and define letters in the English alphabet. English alphabet has letters A, B, C, D, E, F, G, all the way up to Z. So we go ahead and draw a huge syntax diagram, okay? Let's just say for numbers, okay? Numbers start from digits, start from 0 to 1. All right, 0 to 9. Sorry, 0 to 9. Let's say for a particular programming language, we want to go ahead and define numbers from 0 to 1. All right, so how are we going to be doing that? We're going to be using a following notation. So digits, let's say, starts with 0. Digits can also start with 1. Digits can also be 2. It can also be 3. It can also be 4. Let's say just for this particular programming language, we want digits to be only up till 4. And then, oops, sorry for that. Let's draw a straight line. And then all of them is joined with a particular arrow. Okay, so this syntax diagram represents that digits can either be 0, 1, 2, 3, or 4. Any digit apart from that will produce a syntax error. So if the programming language says, let's say in the programming language, it's defined as digit equal to 5, in the error report, we will get an error. So we're going to be getting an error. Let's say this is the line number 5 of the programming language. It's just going to say line 5, syntax error. Okay, so this is what the syntax diagram is going to be helping us to represent. All right. Now let's take a look at how can we define something in Backus-Naur form. Okay, so I'm just going to label this as SD, meaning syntax diagram. And we're also going to be taking a look at Backus-Naur forms. All right. Okay, so the way that we define it in Backus-Naur form is by saying in the following way. So the BNF form is going to be the following manner. Digits, then we define it using 2 colons and equal to 0, 1, 3, 4. Okay, the bars that you're seeing over here, these bars, okay, these bars represent the OR category. That means it can be 0, or it can be 1, or it can be 2, or it can be 3, or it can be 4. That means any one of them will work. Okay, this defines the set of rules. So basically, left-hand side double equal to RHS. This means this defines the LHS. Also, by one rule of thumb, this should never be caps, meaning this should always be small because variables are made with the first letter capital. So if you had written digits, this would mean that this is a variable, and this would turn out to be incorrect. Okay, you cannot do that. And we will be ending up using variables in Backus-Naur forms as well. So this is a variable. This is not something that you can define. Okay, this is user dependent. So with that being said, let's go ahead and move on to the next stage. Let's say you want something to be like, the programming language can also define a letter followed by, let's say, the passwords. Okay, let's say for a website, the password requirement is a letter followed by a digit. How can you go ahead and define this using a Backus-Naur form? Okay, it's pretty simple. So let's say you've got a following syntax diagram for digits once again. All right, for digits, let's say this is going to be 0. Then let's say it's 1, and then let's say it's 2. These are the only digits. All right, let's say these are going to be my only digits. Then let's say for letters, we are defining the small letter A. Then we're defining the small letter B, and then the small letter C. All right, and then we put an arrow. All right, so once we have given that notation, then we can define a following Backus-Naur form. The first requirement is that we have a letter followed by a digit, okay? Letter followed by a digit. So first we're going to be putting letter and then we're going to be putting a box, okay? Don't put letter over here, actually. You put letter, followed by digit, okay? This is going to be my Backus-Naur form, let's say for password. So the rule, so for the object that you're setting up the rule, you're setting up the rule for a password, you write the object name here, okay? And then followed by letter, followed by digit. If you've got more conditions, that's how you set it up. So how do you go ahead and put it in Backus-Naur form? It's very simple. What we want to do is we want to define passwords. So we write in, oops, sorry. So how to represent it in Backus-Naur form? So in Backus-Naur form, it's going to be password colon equal to, again, remember that this must be small, followed by letter, followed by digit. Now, this symbol over here, this greater than and less than symbols represent that the letter can be variable. The letter can be an A and a B or a C. Anything other than these three is going to be incorrect, and it's going to produce a syntax error. And we don't use an or sign because we wanted one after the other, all right? So that's why we produce it. Now let's say that we want that the password can be just a digit or just a letter, or it could be a letter and a digit. Then how do we go ahead and define it? So let's say we have got our password over here, password. We can have a letter followed by a digit. We can have a letter and that's the end. So what we do is we go ahead and draw another arrow from this. That means now it's going to check for, okay, there is just a single letter and there's nothing else. That means it's going to go to this arrow and then just get out. Or it could be a letter followed by a digit and then it's going to be getting out. Or it could be directly a digit. So how do you do that? So it could directly go to digit. So how can you go ahead and perform that? Now this arrow over here connects it to the end. That means it's going to be going through this path, this path, this path. We want an arrow to connect from this to this if we just want a single digit, right? So let's go ahead and do that. Can connect the arrow over here. That means it's going to go to this directly. It's never going to be going into a letter, digit, and then it's going to just exit. To represent this in a Backus-Naur form, we can go ahead and use the following format. Password colon equals to could just be a letter, or this could be letter digit, or this could be just a digit. So digit. And there you've got a defined Backus-Naur form. The next thing is, let's say we repeat something, all right? We repeat something. So by repeating something, it's like that a value can have constant, like it can have multiple letters. Like let's say the password cannot have a single letter, but have multiple letters, all right? It must have multiple letters. Let's forget digits for now. Let's see it's going to be having multiple letters. So again, we're going to be pulling an arrow to password, letter. It could be a single letter, or it could recur back and then take inputs like a loop, right? It's like a loop. It's going to have multiple letters. So in Backus-Naur form, repetition is formatted like this. Password colon equals to letter, or it's going to be followed by letter or letter password. Now, by that, what does it mean? Let's say you have input one letter, and then you put another letter. So if you want to input another letter, what password is going to do, it's going to call password once again. Because inside password, you've got the condition of another letter, or already another letter exists, okay? That's going to be, let's say, your previous letter, your first letter. And then another letter already exists, and you input another letter, right? A is already there, it's verified, it's checked, and then again you input B. So what password is going to do is going to enter password once again, and then it checks that, all right, a single letter, oh no, there's another letter. So it's going to go to its OR option to check it out. In the OR option, it verifies that yes, there is a first letter. Now there's a second letter. So it's going to call password once again. And password again allows for it to have another letter or a letter password. That means it can call password once again from within it. And this is going to recur. It's going to keep recurring as long as you're going to be having multiple letters. It's just going to recur itself and then allow it to verify. All right. So again, it's called password and it has an option for another letter. So yes, this is a valid password. And then it again continues if you're going to have more letters. So this is a concept of recursion in Backus-Naur form, right? In Backus-Naur form, then we can come up and we can have recurring concepts in Backus-Naur form. All right. Lastly is something called an assignment statement, right? We want to assign something, like let's say 1 plus 2, 2 plus 2, right? 1 plus 2, 2 plus 2, etc. Stuff like that. So how are you going to be going ahead and assigning it in the Backus-Naur form format? So it's going to be in the following format. Assignment statement is going to be a, let's say, a variable equal to, because obviously with an equal to, that's to assign it, right? Equal to, followed by, now remember, circles are used for something that's fixed. It's a fixed operator. You don't change it. But variable is something that depends on the user, what the user inputs. Followed by another variable, followed by the operators. If you want to add, subtract, so operators, remember, is addition, subtraction, division, multiplication. Followed by the next variable. And that's it. Sometimes some question papers might have the ending syntax. Not all years do have it, but this is optional. Okay, so I'm just going to highlight it in yellow. This actually pretty much varies. Okay, so this is how something is assigned, because this is the format of A is equal to B times C. So it follows the following format. That's how you can go ahead and assign values, assign stuff, right? So that's how assignment statements work. All right. So now how do you go ahead and write assignment statements in Backus-Naur form? Very simple. If you can understand the syntax diagram, assignment statement, all right, is going to be double equals to value, and then we put the fixed value equal to value operator. It's going to bring this down. Value, and again, the variable ending syntax. I'm just going to highlight it in yellow. All right. So this is how an assignment statement is written in Backus-Naur form. Now, in our question papers, once again, we just need to go ahead and recognize and draw syntax diagrams. All right. That's the thing that we pretty much need to do. Now let's go ahead and do a question from a past paper. All right, so this question is from the 2023 3-3 May-June session. All right, so let's first take a look at what the question is telling us. several syntax diagrams are shown. All right, so there you go. You can see how the operators are functioning, how the digits are functioning, how the symbols and letters are functioning, and we also got a password syntax diagram. All right, so the first part of the question says, state whether each of the following passwords is valid or invalid and give a reason for your choice. So let's take a look at the syntax diagram for a password given according to the question. The password is letter, digit, symbol. Now, the letters can repeat. See, it can repeat. The digits can repeat, and the symbols can repeat. It starts with a letter, by the way, and followed by a digit, followed by a symbol. It's not like it can start with a digit or it can start with a symbol because we don't see the downward arrows or the upward arrows pointing to the digits. So let's go ahead and do this question. So D-pad 99 symbol, right? A symbol D-pad 99, right? So by noticing this, we can definitely say that, yes, this is valid. It follows letters, repeated numbers, which is possible, or digits, and then a symbol, which follows the rule, letter, digit, symbol. And again, those are repeated. So valid. So for the reasoning, we can just simply write multiple letters followed by multiple digits followed by a symbol, which follows the syntax diagram. Now the next thing, or the next question says, DAD symbol digits. Now the problem arises. What's the problem? You first need to have letter, digit, then symbol, not a symbol and then a digit. This is invalid. The reason being, symbol precedes a digit, not following the syntax diagram. All right, let's look at the next part of the question. ADY 1, 2, 3, and then a question mark. Now, you cannot just go ahead and rely on these and the rule of passwords. We got to go ahead and have a good look at every single syntax. And in the letter section, we've got DAD, I think, right? Sorry, ADY. So ADY is present in both the letters, right? Then followed by, we've got 1, 2, 3, right? 1, 2, 3. All of 1, 2, 3 over here, let's have a look. Yeah, 1, 2, 3 is present in the digit section. But a question mark is not present, sorry, over here. A question mark is not present in the symbol section, right? But notice that the password contains a question mark. This is an invalid syntax. It's not a rule. So invalid. Question mark symbol is not defined in the symbol syntax diagram. The next question says complete the Backus-Naur form, BNF of the syntax diagrams shown. Symbols, let's take a look at it. Symbols can be $sign, it could be a percentage, and @ and hashtag. So let's go ahead and complete it. Symbol could be a $sign, or symbol could be a percentage sign, or it could be an and sign, or it could be an @ sign. Sorry, my at's shaky, and it could be a hashtag. Now, also do know that you need to follow the sequence of the symbol of the syntax diagram of the symbol of the symbol itself, right? The syntax diagram. So first is $, percentage, and hash, @ and then hash. So you got to go ahead and follow symbol, dollars, percentage, and @ and then a hash. You need to follow the sequence. Same goes for letters. You go ahead and you take a look at what the letters can do. A, D, P, R, Y. So you can write A or D or R or P or Y. Okay, you need to follow the syntax of it. Now the thing is a syntax diagram. An identifier begins with one or more letters. Okay, so it says an identifier begins with one or more letters. All right, followed by 0 digits, so no digit or 1 digit. All right, no digit or 1 digit or more digits. Okay, so digits can also repeat themselves. Valid letters or digits are shown in the syntax diagram. So draw a syntax diagram for the identifier. All right, so let's go and start drawing a syntax diagram for it. So firstly, let's go ahead and draw 2 boxes because we need letters and we need digits. Okay, letters and digits, followed by arrows. So we've got letters, digits, identifier. So you can have a single letter, right? You can have a single letter. The letter could recurse. And it could end, because notice that we've got one or more letters. So one letter or more letters, and then it ends. Or after this, we could have digits or more digits, and then the code ends. Or we could have 0 digits. So for 0 digits, the code ends this way. So if we are trying to label it out, 1/more letters ends after letters only, one or more digits, and this finally ends after digits and letters. So this is the best way to understand this syntax diagram. Now, obviously, you don't need to kind of write this in the question paper while you're kind of doing it. The ones that I wrote with red is just for understanding purposes. So that's the way you go ahead and draw a syntax diagram for given conditions. These given conditions may also be given for Backus-Naur forms. Now, how are you going to go ahead and do a Backus-Naur form? Okay, in this case, you might be going ahead and given some space or multiple lines. The reason being that this recursive function, all right, must be stored in different identifier variables. So what do I mean by that is if I were to write the Backus-Naur form notation of this is how I would write it. So repeat letters can be a single letter or letter repeat letters. Repeat digits can be just a single digit or repeated number of digits. So digit, repeat digit. Then I would write identifier. It could just be a single letter. So letters, or it could be repeated number of letters and repeated number of digits. Or it could just be repeat letters, or it could be repeat letters, repeat digits. Right? So letters allows for a single letter and then it ends. Repeat letter allows for repeated number of letters and then it ends. Or repeated letters and repeated digits allows for repeated letters, digits, and then it ends. Now, technically, you could go ahead and also erase this part out. Okay, this is not necessary. If you would have written your answer in a matter of like this, it would also be correct, because repeated letters allows for a single letter or repeated letter and it ends. So this syntax diagram is this Backus-Naur form is also correct. Okay, this is also the correct notation of the Backus-Naur form of the question itself. Okay, this is how, if I were in a place that I needed to write the Backus-Naur form, I would write the Backus-Naur form in this particular manner. So with this, it ends the video of Backus-Naur forms. and syntax diagrams. If you would want to take notes, I'm just going to go ahead and go through them, skim through them. You can go ahead and take a few screenshots. But syntax diagrams and Backus-Naur form notations are used in the following manner. And this is something that is called syntax analysis. This is pretty important for the question paper. And that's pretty much it. So thanks for watching. I'll see you in the next video.